This is the lesson for R-9, which deals with transformations. This comes from chapter 6 that we did a few months ago. All right. So with transformations, there are 4 different types of transformations. You always remember, you always move from A to A prime, B to B prime, and C to C prime. You always go from the letter to the same letter prime. You can't go, for example, from A to B prime, always from the letter to the same letter prime. Remember that a translation, remember we put in a little box around the S and L. Remember that a translation slides a picture. It moves it from one place to another place. So maybe this little stick figure guy was sliding over to the right. Maybe this rectangle went up and to the right, or maybe it went down and to the left. We really can't tell from this one, but you're just sliding it from one place to another place. A dilation makes a picture bigger or smaller by multiplying by the scale factor. It's the only one that makes it bigger or smaller, changing its size. A reflection is that flipped opposite mirror image. Remember that you could do a reflection over the x-axis, like that one is, or a reflection over the y-axis, like the other one. You should be able to fold your paper, and those 2 shapes would match up perfectly, including the letters. Notice that if we folded it, the Q would match up with the Q prime, the P would match up with the P prime when we would fold it. A rotation is the only one that turns the picture, and we'll talk about clockwise versus counterclockwise and how many degrees in a little bit. So if we take a look at this first one, all right, the first set of questions that you'll have today deal with translations. Again, remember that we always go from the letter to the same letter prime. You have to count how many places left or right that you move, and then how many places up or down that you move. So for example, in this first one, we are going from A to A prime. So we are going right 1, up 1, 2, 3, 4, 5. So we're going right 1, up 5. So our rule, that's what you would write as your answer. We're going right 1, up 5. Now remember, you don't have to choose A and A prime. We could choose any letter and the same letter prime. So if we chose B and B prime, it would be the exact same thing. Right 1, up 1, 2, 3, 4, 5. In the middle one here, if I choose A and A prime again, this time I'm going right, or I'm going left 1, 2, 3, 4, 5, 6 places to the left. And then I'm going up 1. So this one would be left 6, up 1. Sometimes you'll be given the rule. We're given the rule and we need to draw the new picture. So in this one, we're going left 3, down 4. So starting at D, we're going left 3, 1, 2, 3, down 4, 1, 2, 3, 4. This is where my new D prime would be. Remember that little apostrophe is called prime. Starting at E, left 3, 1, 2, 3, down 1, 2, 3, 4. This is where E prime would be. Then we have F, 1, 2, 3 to the left, 1, 2, 3, 4 going down. This is where F prime would be. Connect the dots to form your picture. Notice that it is the same exact size, same exact shape. We just slid it to the left and down. Then we need to write down the coordinates. When you write down coordinates, coordinates always have parentheses and they always have a comma. So your first number inside your parentheses is how many you go over. Your second number inside the parentheses is how many you go up or down. So where is D prime? Well, when we start counting for coordinates, remember we always start right in the middle at 0, 0. So starting at this green dot right here in the middle, we are going left 1, 2, 3, 4. We're going over to -4 and down to -3. So over to -4, down to -3. E prime is over to -4, down to -6. F prime is over to -2, down to -6. So again, a translation slides the picture. The next type is a dilation. You get a dilation by multiplying by the scale factor. They will tell you what the scale factor is, and you just have to multiply all the coordinates by whatever they tell you. So in this first one, we have a scale factor of 3. We need to multiply each of these by 3. So 3 times -2 is -6. 3 times 0 is 0. I like to put my answers right underneath just to stay a little bit organized. 3 times 0 is 0. 3 times 2 is 6. 3 times 1 is 3. 3 times 1 is 3. Now that I have my new coordinates, now I need to graph my new picture. So over to -6 up to 0, over 0 up to 6, and over to 3 up to 3. Here is my new triangle. Now this triangle is, because we multiplied by 3, it is 3 times bigger than the original because we multiplied by 3. I'll be able to show you this a little bit better in this middle one where we have to multiply all of them by 2. So multiplying all of these numbers by 2, the new triangle is going to be twice the size of the original one. So when I go to graph it, I have over to -6 up to 0. I have over to -6 down to -4. I have 0, 0. That one actually stays in the same spot, and 0, -4. So here's my new rectangle. This new rectangle is twice the size of the original one. Notice that my original one was 2 high. Now it's 4 high. It was 3 wide. Now it's 6 wide. It's double the size, or twice the size, 2 times the size of the original because we multiplied everything by 2. Now, when is it going to get smaller? It's going to get smaller when you multiply by a number that's in between 0 and 1. So 1/2 is 0.5 as a decimal. So I'm going to multiply all these by 0.5. So 0.5 times -6 is -3. 0.5 times 4 is 2. 0.5 times -6 is -3. 0.5 times -4 is -2. 0.5 times 2 is 1. 0.5 times -4 is -2. So over to -3, up to +2, over to -3, down to -2, and over to 1, down to -2. Notice that my new triangle is half the size of the original. The original blue triangle was 8 high. Now it's 4 high. The original triangle was 8 wide. Now it's 4 wide. It is literally half the size of the original because we multiplied everything by 1/2. The next kind is a reflection. Now, the most common mistake in a reflection, remember that a reflection is that mirror opposite image. All right. The reflection is that mirror opposite image. So you would have to count how many places to that line and count the same number away from it. The biggest mistake that people make is doing it over the wrong axis. This one says to do it over the x-axis. This middle one says to do it over the y-axis. So please make sure that you're doing it over the correct axis. Otherwise, it'll be totally wrong. So you want to count how many places to that line and then count that same number away from it. So A is 1, 2, 3, 4, 5 places to it. 1, 2, 3, 4, 5 places away from it. This is where A prime is. B is 1 place to it. 1 place away from it is B prime. C is 1 place to it. C prime is 1 place away from it. So this is our new flipped opposite mirror image. This is our new reflection. Then you're going to have to say the coordinates of your new shape. So A prime is over to -1, down to -5. B prime is over to -3, down to -1. And C prime is over to -1, down to -1. When we take a look at this middle one, we're doing a reflection over the y-axis this time. So we're counting to that yellow line, 1, 2, 3, 4, 5, 6 places to it. 1, 2, 3, 4, 5, 6 places away from it. This is D prime. E is 3 places to it. E prime would be 3 places away from it. F is 1 place to it. F prime is 1 place away from it. Again, notice you have that flipped opposite mirror image. Same size, same shape. It's just that mirror opposite image. So where is D prime? It's over to 6, down to -1. Where is E prime? It's over to 3, down to -1. And where is F prime? It's over to 1, down to -5. When you have a diagonal line, you want to count diagonally corner to corner to the line and diagonally corner to corner away from the line. So when we start off at H here, H is 1, 2.5 to that line, 1/2, 1, and 2 away from it. This is where H prime would be 2.5 places corner to corner to the line, 2.5 places corner to corner away from it. I is 1 place corner to corner to it, 1 place corner to corner away from it. This is where I prime would be. And then G is 1, 2.5 to it, 1/2, 1, and 2 away from it. This is where G prime would be. So connecting our dots, got a little messy there, looks like that. Again, it's that flipped opposite mirror image. You should be able to fold your paper and those should match up perfectly. If they don't match up perfectly, you did something wrong. So when we take a look at the coordinates, G prime is over to 4, down to -1. I is over to 1, down to -1. And H prime is over to 1, down to -4. So again, reflections are those flipped opposite mirror image. The last type that you have are rotations. Now remember, you have to know the difference between clockwise and counterclockwise. Clockwise, just like this picture is indicating, clockwise goes around like the hands of a clock. All right, so clockwise goes around like that. Counterclockwise is backwards clock. Think of a clock spinning around backwards. All right, so we're going around and around like that. If you move 1 quadrant, it's going to be 90 degrees. If you move 2 quadrants, you're going to go 180. What the heck are quadrants? Well, if you forgot what quadrants are, remember that graphs are divided into 4 different regions. You have those 4 corners of the graph. Each one is called a quadrant. So taking a look at this first one, starting off with this blue one, that's our original one. If we move over to here and we go 1 quadrant over this way, notice how my picture is moving. It's moving in a clockwise direction. So this one would be 90 degrees clockwise. We're moving 1 quadrant, so it's 90, and we're going in a clockwise direction. In the next one, if we go this way around to get down to this double primed one, we're moving 2 quadrants, so that is 180. Even if we went this way, we'd still be moving 2 quadrants and it'd still be 180. With 180, we don't say clockwise or counterclockwise. You just say 180. And in this one, we're going from the original blue one down to the triple prime. We're moving 1 quadrant. So again, it would be 90, but this one would be counterclockwise because we're going backwards clock. The last type of question that you have today are sequences, where you're not doing 1 thing to a picture, but you're doing 2 things to a picture. So remember, you're going to label your first image with single primes, And then you're going to label your second image with double primes. So doing this first one says do a reflection over the x-axis. So I'm going to make my x-axis darker. I'm going to count how many places to it and then count that same number away from it. So A is one place to it. A prime is one place away from it. B is two places to it. B prime is two places away from it. C is 1, 2, 3 places to it. 1, 2, 3 places away from it is C prime. Connect your dots. And that is the reflection over the x-axis. But then using that new orange single primed picture, we have to do a dilation of 2. Well, again, remember, if you do a dilation, you have to multiply by the scale factor. So when I take a look at A prime is really at 1, 1. B prime is really at 0, 2. And C prime is really at 2, 3. So I need to take all 3 of those and multiply by 2. So 1, 1 will become 2, 2. 0, 2 will become 0, 4. And 2, 3 will become 4, 6. So over to 2, up to 2, this is my new A double prime. 0, 4 over 0 up to 4, this is my new B double prime. And 4, 6 over to 4 up to 6, this is my new C double prime. Again, with these sequences, you end up with 2 pictures on each one that you're drawing. 3 pictures total. In this one, the pictures are already drawn for you. You just have to say what's going on there. So how do we get from the A to A prime? How do we get from the blue one to the red one? Well, notice that the picture is turning. So this would be a rotation because it is turning. More specifically, how many degrees? It is 90 degrees because we're moving 1 quadrant and we are going clockwise. Then how do you get from 2 to 3? All right, how do you get from the single prime to the double prime? Notice that our letters are being flipped. Notice that it's that flipped opposite mirror image. We're not just sliding it because notice the letters, the B and C, are backwards. So this has to be a reflection. And more specifically, it is a reflection over the y-axis. So just as a quick little reminder, what is the only transformation that the size changes? The size changing, that is a dilation. That's the only one that the size changes. What's the only one that turns a picture? Turning a picture would be a rotation. Which one flips a picture? Flipping it is that flipped opposite mirror image. That is a reflection. And the one that slides a picture, slides, remember the S and L in translation stands for slide. That is a translation. Again, this is a good graphic that I like, that I think people is helpful for people. A translation slides the picture. The kitty cat slides from one place to another place. A dilation makes the kitty cat bigger or smaller. A reflection is that flipped opposite mirror image. It could go side to side or up and down. And a rotation turns the picture.